Hello, this is Jeff Dunne. I'm an assistant professor in peanut breeding and genetics at North Carolina State University. Today I'll be presenting some work on improving sensory quality and composition based on sensory panel evaluations and the identification of novel sources of germplasm contained within the NCSU Peanut Breeding Program seed bank. Each year, the NCSU Peanut Breeding and Genetics Program tests lines in a sensory panel through the Uniform Peanut Performance Test. The table presented was a summary report that was developed to determine if the lines that were submitted to the UPPT were performing better than the cultivars developed within the program and the sensory checks. Based on the table, the 3 lines presented have a higher roasted peanut score, on average, when compared to the cultivars and the sensory checks, but a lower sweet score when compared to each of those groups and a higher bitter and bitter aftertaste score compared to the sensory checks. Typically, any improvement in these major categories would suggest that we're headed in the right direction. However, when you consider that the industry views the sensory checks as somewhat bland or not meeting their standards or expectations, are these subtle improvements actually having an impact? In order to make more significant improvements to peanut flavor, additional germplasm resources need to be identified to push these sensory attributes well above those of the sensory checks. One potential place to review germplasm resources is within the NCSU Peanut Breeding and Genetics Program's seed bank. There is a very interesting NPR article that was published in 2016 describing the search for an ancestral peanut line that was brought over by slaves in the 1600s to the Carolina region and thought to be lost following World War I. A chef from South Carolina was in search of this seemingly mythical peanut that has been described as having the best roasting aroma and flavor for use in his restaurants. During his search, he had contacted my predecessor, Dr. Tom Islip, in hopes that he might have some information regarding the line. It turns out that Tom had the line, or potentially just something that was superior in sensory attributes, and it was labeled Carolina Runner number 4. Under the same pretenses, we then thought the 700 lines in the collection had never been screened for flavor, and that maybe we would be able to find other lines within our collection that portrayed superior sensory and roasting quality than the sensory checks and could be used in our breeding program for that purpose. In order to determine if any of the lines within the NCSU Peanut Breeding and Genetics Program seed bank could be used for improving sensory quality and composition, a subset of lines were selected from the seed bank based on quantity and agronomic or disease resistance quality. The lines were then submitted to the USDA ARS Market Quality and Handling Research Unit under the direction of Dr. Lisa Dean for roasting and sensory quality evaluations. Lisa currently evaluates the lines that are submitted to the UPPT, which then allows for the evaluations on the germplasm lines to be related to the UPPT information. After the evaluations, these will be grouped based on multivariate approaches to identify groups that have high, average, or poor flavor. Lines within the high flavor category will be selected and used in a specific crossing block with Bailey 2 for the identification of gene blocks that are associated with improved sensory quality and composition. Presented is a list of the selected germplasm lines from the seed bank. There are a number of lines within the subset that appear to be the same. However, these lines were selected from bulks or adapted from a single line through mutation breeding and assumed to be different. For instance, each line within the Robusto collection contains single base pair differences developed through X-ray mutation breeding efforts. As mentioned in the project overview, 210 lines were randomly selected as a subset of 740 lines for the sensory quality attribute evaluations. When submitting the germplasm lines for flavor panel work, each line needs to be roasted in replicates. The paste of each replicate is sampled by a different flavor panel group within the USDA ARS Market Quality and Handling Unit, and then scored by a panel for each of the 22 sensory attributes listed below. The most challenging part of this work, considering that each of the germplasm lines was in such low quantity, was getting the roasting time and color correct without wasting too much seed. It is known that roasted peanut score is one of the main sensory attributes that breeders use for making selections on flavor improvement. It is also known that in order to optimize roasted peanut values, the roasting time follows a specific curve. Roasted peanut flavor is often optimized between 10 to 12 minutes for roasting time. However, shorter or longer roasts can drastically impact the evaluations and cause problems with selections. Therefore, all peanut samples were roasted and pasted to a common color value. Similarly to roasted peanut flavor, there is an optimized roasting timing to achieve the most reliable sample for tasting. In the figure, the Hunter L score decreases as roasting time increases. This negative correlation suggests that the longer the peanuts are roasting, the darker the roast and paste sample. In evaluations of the germplasm lines submitted to the USDA APRES Market Quality and Handling Unit, replicates of each sample were separated into color groups ranging from group 1 to 7, where groups 1 and 7 represented the least reliable for sampling, and group 4, between 49.6 and 50.7, represents the most reliable. When looking at the roasting time by roasting bee color, the separation of each group is most likely due to purpling, suggested by the Hunter B score, and is likely due to the testicolor prior to roasting, and that these lines don't represent improved cultivars or breeding lines relative to seed color. Here, only 69 of the 210 lines that were screened achieved color scores in the optimum or most reliable color group. Careful consideration of the group information was used in the final selection of the lines used in the crossing block with Bailey 2. The USDA APRES Market Quality and Handling Unit also averaged the most useful sensory attributes by color group. In the tables, the group 4 lines are highlighted and often showed higher sensory quality when compared to other groups, but not always. The group 4 lines were among the highest for roast peanut, sweet aromatic, and sweetness, and considered lower in bitterness. These scores are also highly correlated to the Hunter L range. In addition to the color group evaluation, the lines were also analyzed in a multivariate approach without considering the color group initially. To accomplish this type of analysis, the data was first subset based on sensory attributes that had a significant variance, suggesting that it would be easier to separate the lines based on these attributes. A significant attribute was considered if the variance was greater than 0.10. Based on this approach, 11 out of the 22 sensory attributes were used. Next, the sensory attributes were analyzed for correlations among each trait. In the chart, positive correlations are represented by reddish blocks between attributes, and negative correlations are depicted in bluish blocks. The darker the color, the higher the correlation, regardless of the direction. There are a few notable results from looking at these correlations. In number 1, the dark roast was positively correlated with roast peanut and sweet aromatic scores. However, it was also correlated positively with bitterness, which is always a concern. In number 2, the raw bean scores were positively correlated with moisture content, roast color, and paste color, meaning the higher the under roast score, the higher the water retention and brighter the roast and paste color, which makes sense. In number 3, if we look at the cardboard score, this too has the same correlation as raw bean, meaning we'd be more interested in a darker roast with some of these germplasm lines, which could be problematic. In number 4, it should be noted that with these materials, the roast peanut, sweetness, and sweet aromatic scores are positively correlated, meaning the improvement of one leads to the improvement of another, and it may be linkage related. In the multivariate approach, the lines were clustered using the selected 11 attributes, and it was determined that 3 groups resulted from the clustering approach. The cultivars or flavor checks, which were also submitted to the flavor panel, were separated to see which groups these lines would most likely have been included. The high flavor cluster is identified by cluster number 3. The average flavor cluster is identified by cluster number 2. The poor flavor cluster is identified by cluster number 1. If we look back at the color group scores, the cluster segments contain varying lines within each color group. Since color group was such a high priority, lines were selected mainly from cluster 3 that were representative of the color group number 4. Based on the principal component results, each PC could be identified using a descriptive name. For instance, PC1 is weighted more heavily by roast color, paste color, dark roast, and raw bean, meaning this principal component is most likely separating out color attributes of each line. The second principal component is separated mainly by roast peanut, sweet aromatic, sweetness, and bitterness scores, suggesting this principal component concerns flavor. The same could be suggested by each of the additional components and are labeled in the table. Based on the results of the multivariate analysis, lines were almost exclusively selected from cluster number 3. However, there were other lines that were grouped in cluster 2 or 1 that were identified as having strong flavor characteristics. Using the results, 2 lines, Chimera and NC Bunch, were selected to be used in our summer crossing program with Bailey 2. In addition, the 16 lines presented in the bottom table are growing in an increase to be further evaluated by the USDA ARS Market Quality and Handling Unit in the fall to verify our initial findings. The lines selected for crossing, Chimera and NC Bunch, will be crossed to Bailey 2. We're using Bailey 2 for a number of reasons. First, Bailey has been a very successful line in the Virginia-Carolinas region. Bailey 2 will be replacing Bailey next year as a near isogenic, high oleic variety that exhibits similar growth habit, disease resistance, and even higher yields than Bailey. Second, the NCSU Peanut Breeding and Genetics Program has developed an internal reference genome of Bailey 2. Used in concert, the whole genome sequencing of Chimera, NC Bunch, and a poor flavor line, Jenkins Jumbos, could help identify differential gene blocks and SNP markers involved in improved sensory quality targeted for marker-assisted selection. Our goal is to use these markers for selection in early generations, altering the selection response to flavor early on in cultivar development. During development, the progeny families of the Chimera and NC Bunch crossing block with Bailey 2 will be screened by the USDA ARS Market Quality and Handling Unit to provide further evidence of flavor improvement if the blocks are segregating among these families. For further information on the Bailey 2 reference genome and the whole genome sequencing, please see Newman et al. Performing an internal reference genome assembly, whole genome sequencing, and in silico digestion for improved efficiencies in marker detection for Virginia type peanuts, submitted in the Joe Sugg graduate student poster competition. I'd like to thank the sponsors and efforts made to make this project possible. The project was sponsored in part by Mars Wrigley, the North Carolina Peanut Growers Association, North Carolina Foundation Seed Producers Inc., and the North Carolina Certified Seed Association. In addition, I'd like to thank Dr. Lisa Dean, Keith Hendricks, and the entire flavor panel of the USDA ARS Market Quality and Handling Research Unit for their diligence on this project. If you have any questions regarding this project, please feel free to call me or email me. Thank you.